This is the Tylophone, my very own homemade open source synthesizer. It's got a monotonic piezo buzzer, you play it with a stylus, and it's got a sweet 4-bit glyph display. This is how I made this one and how you can make your own. Now, I've always been kind of a musical guy. And I like to make things, but I've never made an instrument. Well, there was middle school, but I don't want to talk about it. Anyways, I want to make a synthesizer because synths are awesome. And I want to make it on my own custom designed circuit board that anyone else can download and build for themselves. I think I want to imitate the very popular stylophone because it seems really easy to do. Now, stylophones have been around forever. And basically, you take a conductive stylus and run it on a set of conductive keys. And when you complete the circuits, it plays notes. It's basically just an array of buttons with a common rail, and conveniently, that is something I can wire up on my ESP32. So with a piezo buzzer that can play any frequency, I can hook up each key to a different frequency and suddenly play all 12 notes. But honestly, if all I'm doing is playing 12 notes, I might as well just get a cheap baby piano from the dollar store. Do I look like a baby? Assuming you said no. No. What I need are some features, because that's what makes it a Tylophone. And yes, that's what I'm calling it. The pun is awesome. Feature number 1, volume control. I can annoy my wife all day at 100% volume, but I wouldn't dare do that to my soon-to-be-born daughter. That's what 50% volume is for. Feature number 2, octave changing. I want to be able to have a 2-octave range because I feel like so many of these cheap pianos are limited by having to awkwardly bounce between keys on 1 octave. I want to. Feature number 3, waveform changing. This one's a little bit more niche. Let me explain what I mean. Any speaker or any sound producing device makes that sound by vibrating air molecules back and forth. That's what sound is, airwaves. With a guitar, it's the string. With a trumpet, it's your mouth. With a clarinet, it's the reed. And with a piezo buzzer, it's this diaphragm. Now, this buzzer has 2 states it likes to be in, on or off. And by changing how fast you switch between on and off, you create different tones. However, if all you do is just starkly turn it on and off, it produces this kind of robotic sounding square wave. But if you pay attention to what happens in between the on and off states, you can ramp it into any shape you want. For example, if you smoothly oscillate between on and off, it produces this nice sine wave. And if you kind of linearly ramp up and down, it produces a triangle wave. Now, I want to be able to make all 3 of these waveforms, square, sine, and triangle. And thanks to my ESP32's DAC, I can totally do that. Now, most pins on the ESP32 are pretty simple. It's like a light switch, on or off, voltage or no voltage. But there's one pin that's like a dimmer switch. It can ramp in between voltages. And if I take advantage of this, I should be able to make any waveform I want coming out of the buzzer. And finally, feature number 4, ratcheting. Now, if you don't know ball, ratcheting is what happens when you have a sick beat drop like this. I want my thing to do that. Now, in order to have all these features, I need some way to have a menu. So I need some way to display it and some way to control it. To display it, I've got a 7-segment display.
Shout out clocks.
These are as simple as they look. It's literally 7 LEDs plus a bonus dot, which I will not be using. And to control the menu, I've got a rotary encoder, which is basically able to control anything. You can twist it, you can push it. It's perfect UI design. Now, I have a problem. My ESP32 only has so many pins, and I've actually run out. I can only turn on 4 of the 7 LEDs of my display. I could multiplex, whatever that is. I could use I²C or do some kind of matrix thing for the keys of the keyboard, but frankly, I don't want to. I just want to keep things simple, and I honestly like the design constraint. There are a surprising number of things you can do with just 4 LEDs, and I honestly think I can make a whole user interface. Let's just use 4 and let's get to prototyping. And just like that, I've got a fully functional prototype. And let me just say, the UI is sick. I totally got it working with just 4 LEDs. You can turn the knob to adjust the volume or click to enter the menu where you can select between waveform, octave, and ratcheting choppiness. Now, let me come clean about something. I did use AI vibe coding to make this happen, but before you unsubscribe.
Hold on, they're lithium.
I'm not that good of a programmer. And frankly, I couldn't have done this project without the help of AI, but I went back through and I took notes and I learned from the code, and I honestly couldn't have done it any other way. I'm still personally proud of this project, and I can assure you that the actual routing of the circuit board, it's all me, baby. So please continue to subscribe and continue to watch this video because the circuit design is really fun. Now, KiCad is this super powerful open source PCB design software. And before I opened it up, I knew nothing about PCBs, but only one tutorial from a channel called The Design Graveyard was all it took to get me up and running. Seriously, if you ever want to design these, go check out this tutorial. It's fantastic.
Okay, so this is KiCad.
You know, it's midnight, but there's never a better time to burn the midnight oil. So let's do it. Here's the basic workflow, and stay with me here. It's really, really cool. First, the computer needs to know what components you're using and how they're connected. So, for example, I've got a rotary encoder with 5 pins. Here's my rotary encoder with 5 pins. And it's connected to my ESP32, so let's make that connection. Once you do this with everything on the board, the computer has a complete electrical schematic.
Why are there so many resistor sizes?
They're bean sized. Look at this. There's so many. But then it doesn't know how everything fits in real life, so you have to add footprints for every component. For example, my ESP32 has pins spaced 0.1 inches apart, so I have to tell the computer to make the holes for it 0.1 inches apart. Once everything has a footprint, you can actually design the PCB, and this is so cool. The computer already knows the size of your components and how they're connected, so it shows you all of their footprints with their connections, and all you do is play connect the dots. One of the coolest things in my opinion is how circuits handle crossing wires. In real life, you can just put wires on top of each other because they're insulated, but with a circuit board, you're gonna cross the streams. So if you need to route a wire and it's completely landlocked, what you can do is punch into the other side of the circuit board, route a wire behind it, and then pop back out. It's called vias, and I thought it was super cool. Once everything was complete, I sent it out to JLC PCB and got 5 of them for 12 bucks.
Guess what came in the mail today? Ooh, that's right.
I think these circuit boards are awesome. The front has all these hand-drawn embellishments and this sick logo and these cool fonts, and the back has instructions for how to use the menu and a QR code to yours truly. And I'm just stoked about them.
Now I just got to take this and put it on there.
So I was one quick solder away from having everything working. What do you mean I forgot a ground connection? It's okay, I was able to jumper the ground wire with another wire behind it. So I was one quick solder away from having it working. What do you mean none of the keys are connected? It's okay. I was able to jump all of the resistors onto their keys with kind of ugly embellishments, but that's what makes it mine. So, with one quick solder, I...
Let's go, baby.
It's chill. It's chill. It's chill. I also designed this 3D printed enclosure that holds the batteries and a bearing tipped stylus that magnetically slides into it. It covers the QR code, but you know what channel it's for. You know. So here is what it sounds like. I think this synth is awesome. I love the features, I love the menu, I love the vibes of it. It checks off all 4 of my features, and you can build your own. I've included a complete list of all the parts you need and all of the files for absolutely free on my website. So go ahead, order your own, build your own, and make your very own Tylophone. Ooh, that rhymed! That's boss. Also, if you don't want to buy a single thing, a single component or circuit board, I've made a digital version of the Tylophone that anyone can play on their computer or phone that's also on my website, so feel free, play to your heart's content. I've learned an absolute ton about PCB design making this project, and I hope you've enjoyed the video. That's all I've got. I'll catch you in the next one. Thanks.
She was born to play.